This is part 2 of open closed principle. In part 1, we discussed how this principle is violated. So we had the book service class that instantiated book repository class in its constructor, and the book repository class used Entity Framework Core for its data access logic. We also mentioned that if there is a change in the requirements and we need to switch from Entity Framework Core to Dapper, we create a new class called book repository Dapper, but then we need to modify the book service class to refer to the new book repository Dapper class. And that violates the open closed principle. In the previous video that discussed the dependency inversion principle, we had an interface called iBookRepository with an add method, and we let the book service class depend on iBookRepository instead of book repository, and we made the book repository class implement the iBookRepository abstraction. Now, if we need to switch from Entity Framework Core to Dapper, then you can just create a new class called book repository Dapper and let the class implement the iBookRepository interface and have the add method contain our Dapper specific logic. Now, since the book service class depends only on the iBookRepository abstraction, it does not need to be modified. The only change we need to make is in the main method, where instead of book repository, we need to say book repository Dapper. And when the book service class is instantiated, an object of book repository Dapper will be supplied as constructor argument. So if we want to add new repository implementations, we simply have to implement the iBookRepository interface. So our repository code is open for extension. And besides interfaces, we can also make our code open for extension by using abstract classes and virtual methods. Finally, the book service class is closed for modification because it depends on the iBookRepository abstraction, not on a specific implementation. In the next video, we'll talk about the Liskov substitution principle.